Hi everyone, my name is Michael Pro, and I'm working at Epic as a senior physics engineer. So today, I'm going to present you the new advanced Groom Dataflow setup that has been introduced in UE 5.7. So the agenda for today. So we are going through the motivation behind this initiative, so why we decided to change a bit how the Groom was set up. Then I'll introduce briefly the Dataflow framework. So for people who are not aware of or never used of, it will be like a really simple introduction, a really brief one. Then I will go through the Groom integration, the deformation pipeline, and we'll finish by like a simple example to show off like all of that in action. So Groom has been around for quite some time. It has been, I think, released like 5 or 6 years ago. And if a lot of things have evolved since then, the way you were setuping things didn't really change. So you were just doing all your work and all your setup in the host application. That could be Maya or Denny. And just after that, you are importing your Groom, and after you are able to modify it a bit inside engine, and you were using it. But the way you are really setuping things didn't really change. So we wanted to improve on that. We wanted to improve the flexibility on the way we are like setuping things. So for example, if you wanted to add a new attribute in your Groom, you had to go back to the DCC, you have to add the attribute, you have to re-export your asset, you have to re-import into the engine, you have to modify the source code, basically to be able to access these attributes into deformers, into materials. And so it was really a painful process, like with a lot of steps. So we wanted to have like a dynamic set of attributes, something that could be done fully in engine without going back to DCC. And we wanted to have a dynamic set of attributes directly available into deformers or materials. We wanted to have as well more features. So sometimes, for example, we had like a project when we had the simulation and we wanted, for example, a bit of the Groom to be steeper in front and like softer at the end. And unfortunately, it was not really possible. We are not able to select spatially some areas and just modify them. So we wanted to introduce like painting selection into the tool, and we wanted to have like a better bridge with like other editors. We wanted as well to have like a node-based framework in order just to give the users and the artists more flexibility in the way they are setting things. So it was one of the goals, at least. We wanted to have as well a better scalability. So you can see, for example, on the right, like a lot of meta-humans. So it could happen in your project, you could have like, a lot of them. And like you can imagine that like for each one of them, you can have like mustache, eyebrows, you can have hairs, different ones. So at the end, you can have like a lot of assets to deal with. And if at some point during your project, at the end of this one, you say, oh, I want to maybe decrease a bit the computation time and just like reduce the complexity of my Groom, you have to go through each one of them, modify them. And so you have to go back to DCC, re-export them. I mean, it's a really long process. And so we wanted to have a template-based system. So basically, you just define some kind of recipe, and after you can reuse that recipe across like a lot of assets. So this makes like late change possible. Even at the end of your project, you can just say, I'm going to decrease the number of guys by like 10%, and you can apply that recipe on all your assets in a one-click button. And another feature that we wanted to target was like art directability. So I don't know if like some of you have watched like the demo we had like at UE Fest Orlando on like the Witcher one. This was a collaboration with CD Projekt. So this demo was really awesome. And like in that demo, we had like a sequence when the horse was running. It was this one. And I mean, the deformation was really great and awesome. But in that example, we didn't use the Groom for that demo. And one of the reasons was like because we are lacking the art directability. So it was not possible if, say, I want at some point for the tail to be here or here. I mean, it was not possible. For sure, you can simulate like the full tail, but like you were not able to really control exactly where it could be at some point in time. So we wanted to give that freedom on that that freedom to the artist in order to control the tail, for example, with control rig, with airband, and to have to give the artist the full control of the deformation. So it's why we picked Dataflow for that, because Dataflow is a really flexible framework. I'm going now to present you a bit what it is. So I'm not going to go too much in detail. If you have more questions about how it works, I will be around after the talk so we can discuss a bit more. But I'm just going to briefly describe that framework in case you never use it. So Dataflow is like an asset generation tool. It's used for now in most of the chaos asset editors. So it's used for close, outfit asset, flash asset, geometry collection asset, and I think it's going to be used in 5.7 for physics asset as well, generation, and now for Groom asset as well. So it's used more and more. I hope it will be used even more in the future. So it's a really great tool. So I'm just going to describe here really briefly the UI. So for example, on the bottom part, you have all the graph-based widgets. On the top part, you have all the view-based widgets. So the central part of it is the graph editor. So the graph editor is a standard dependency graph in which you have a collection that is flowing from node to node until a terminal node, which is basically writing your asset. On the left side, you have the member variables. On the right side, you have the node details. So it's quite standard if you are used to Blueprint or to other graph-based tool. On the top, you have the construction viewport, simulation timeline, the tool palette on the left, and you have the preview scene, asset details, and scene outliner on the right. I'm going now to focus maybe on some of them because they are a bit different to what you're used to. But for most of them, it's quite, standard for Unreal. So for the construction simulation viewport, their goal is just to give you instant feedback of what's going on. So different kind of feedbacks. The construction one is there just to give you a visual representation of what's going on for each node. So you are going through each node output, and you are going to render the output. So it gives you the freedoms that if you have something flowing from node to node, you can just click on several nodes one after the other, and you can see the evolution of the collection that is flowing in. So it's a bit like Houdini, if you are used to Houdini a bit. So it's really handy, for example, when you are modifying the geometry. For example, you say, I'm going to resample my number of vertices, and I'm going to smooth a bit my geometry or something like that. You can directly see the end result live in your viewport. The construction viewport is used as well for all the tooling. So we have some tools available in Dataflow, and these tools are only opening on the construction viewport. When you want to paint some attribute, to select something, everything will happen in the construction viewport. The simulation viewport is a bit different. The goal is to have the final rendering and the final deformation there. So you are setting this viewport in a different way, because you have in the preview scene, you have an option to put a blueprint. So by default, each asset has its own preview blueprint, I would say. But if you want to do something custom, you can just create your own blueprint, put whatever you want inside, put the blueprint in the preview scene, and it will display something here. So for example, even if we take, for example, this example, this one is a simple blueprint with one asset. But if you want to, let's say, test the scalability of your asset, you can create blueprint with 100 characters running on screen. And you can see, for example, the transition of the LOD or something like that directly into your simulation viewport. You have as well the timeline here, just to record the deformation in case you want some animation deformation there. For the subgraph on the variables, it's quite an important feature for Dataflow because it makes you reuse things as much as possible. So Dataflow subgraph is kind of standard. You just group a lot of nodes there, and after you can reuse that Dataflow graph into the main graph. So it's just a way of reducing the number of nodes in your graph and just making probably less errors when you are going to set up it. So the Dataflow variables is as well super important because you can imagine that without that, all your nodes, I mean, all your graph won't be a recipe anymore. Because like, for example, if you say, I want to target a skeleton mesh for my Groom, you will need to embed the skeleton mesh node inside your graph, and your graph will no longer be a kind of template that will work for every kind of asset. It will be really specific to your asset. So if you do that, you will need to create like a Dataflow asset for each one of your Groom assets. So now we have Dataflow variable, so you can define a variable, you can override that per asset, but the graph itself is like kind of unique and could be used across like all your assets you have. Another widget that is really interesting in Dataflow is the collection spreadsheet, because it allows you just to debug the collection that is going from node to node, and it adapts as well to the selection. So if you want to debug like what's the output of your node, you can just directly see all the groups and the attributes that are like within each group and the values that are within each attribute directly in the collection spreadsheet. So now I'm going to go through like the Groom integration. So what we did to integrate the Groom into Dataflow. So the first thing that we had to do is like to change a bit the data structure. So before, like the Groom was like holding strands and guides, and it was many core internal data that you have to import through the DCC. And these data were like available in deformers and material, but it was like a rigid set of attributes. So we just extended that, and we just added the managerial recollection into the Groom that were holding Dataflow attributes, and these attributes were like available for deformers. We plan to expose them as well in materials in case you want, for example, to define in Dataflow some rendering attributes that could be used in materials, for example. So it's like in the roadmap. I hope it will be quite soon. Here is just a description of like what the managerial collection is, because like I spoke like about collection like since the beginning. Like you saw that it's the main data structure that is flowing from node to node in Dataflow. It has been used as well here, like in the Groom, and it's used in like many of our assets. So a managerial collection is, I mean, to be really simple, it's like a data container. Basically, you define groups, and you define a size for each group, and like all the attributes that belong to that group will share exactly the same size. So it's really easy. For example, you have like an example here. You have vertex group with like n elements. For example, if you say, I'm going to define a position attribute in that group, and the velocity attribute in that group, it will just belong on the vertex group. Both attributes will have like n elements. Same goes for the face group and the geometry group. So once we have that in place, we started to integrate like some nodes to have some feature in Dataflow. And one of the first things we just tried to tackle was like the card generation. So I don't know if you ever used it, but like there's an option like for Groom when you can just generate cards out of the strand. So just to build some LODs. And so, but like the current pipeline is like you have like a button into the Groom asset. You just press the button. It opens a pop-up window. You have like some options there. You just change the option, and it will generate the cards. But like sometimes things could go wrong, unfortunately, and you could not be happy with the end result. So, and it was kind of painful just to figure out like where the issue could come from, because you can't really inspect the intermediate result. You just launch and just hope for the best. So we wanted to change that just to have like more granularity and being able to see intermediate result, and just to have like parameters that could control just some intermediate result. So we added like different nodes to do that. We added like a node, for example, to build the clamps, one to build the geometry, one to build like the texture. And for each one of them, you had like a different set of parameters, and you can directly see the result of each node individually. So which is really handy because you can now start really debugging things and understanding things. Another thing that you wanted to have like absolutely is like having more like binding all the curves coming from the strands or the guides to a skeleton mesh, because like we wanted to have like more art directability. So being able to define a control rig or simulation, for example, of joints, and being able to of the simulation to target that, or directly deforming the curves based on that rig. So we added a node just to target a skeleton mesh. So it was like a transfer of the skin weights. We were like transferring skin weights from like a skeleton mesh that we just set up in Persona Editor. And we were like transferring these skin weights onto the curves. But like again, like sometimes things could go wrong, and you should be maybe sometimes not happy with like the transfer. So we just as well integrated like all the skin weights tool from the Persona Editor, because like artists really loved it, into Dataflow. And so now we have in Dataflow a way of like editing, visualizing, modifying all the skin weights that we have transferred by the node. And if you want some more procedural correction, because you don't want to paint by hand or something like that, you can select some areas and just run a correction node. So it's like a correction node. You have like a different type of correction. You can relax the skin weights, print the skin weights, hammer, clump, normalize. So it's like standard algorithms that are available already into the painting tool that are all available as well in Maya. And you can procedurally like modify them. This tool has been used quite a lot, for example, for clothes, in the clothes resizing project. And it could be used as well for all the assets that we have in Dataflow. Another feature we tackled was like the guide generation. So before, the guide generation was a bit spread out. So the pipeline was more or less, you had the choice to import the guides directly from the DCC. Second option was like you import only the strands and you just regenerate like a part of the guides based on like a percentage of the strands that you wanted. And once you have that, like on the simulation side, when we are like reading the guides, we are just resampling them. We are just like doing some inverse dynamics to get the response. We are like able as well to smooth them. We had a lot of different operations that were done just at runtime. And it was not really necessary when you could do that like way before, like even at editor time. So we wanted basically to consolidate that and just to put more way of like generating them like inside Dataflow. So it's why we had like a lot of nodes for generating them out of the strands, for resampling them, smoothing them, creating LOD generation directly. So there's like a lot more to come in the future, but at least now we have like a lot of options just to generate them. And it works as well with selection. So you can say, oh, I have my strands, I'm going to paint some areas, I'm going to extract that selection, use that selection to generate that many guides, and after I'm going to smooth them in that way. So there's like a lot of flexibility there. And to have like more flexibility, we just added as well the bones tool that is been introduced recently in the Persona Editor. So it's like a tool to add, to wrap around, to move bones wherever you want. So we wanted to add that, like if we wanted to change the skeleton mesh we wanted to target, and if like this skeleton mesh was like kind of dependent of like how the guides were like, or the strands were set up, we wanted to have like a way of like modifying the input skeleton mesh without going back to the skeleton mesh editor and just modifying that here. So we just like added the tool into Dataflow, and now we have like a way of like modifying the bones directly there. And the attributes tool as well has been extended by our team just to have like a lot more feature. And now it's really easy to select things, to paint things, and just to reuse after these attributes that you set up here in the deformers, for example. So now that we went through like all the new way of like setting things in Dataflow, we had to modify a bit the deformation pipeline because we were not really able to use all what we have defined before. So before, like even 5.6, there was like the deformer graph could be used in a Groom asset component, but you only were able to modify the strands, and that's it. And so, but we wanted to have like way more things. So we wanted to be able to define the guides first, to have access to all the Dataflow attributes that you just set up before, and to have like more coupling. And I'm going to explain a bit what coupling means here. So I think we had like some projects in the past where, for example, you had like an asset and you have like different components. And we wanted to have interaction in between these Groom components, but it was not really possible because like each component has its own solver. So you are not able, or its own deformers. And it was not really possible to have like them in the same one, except if you were like merging the Groom component into one and just like being able to access everything, all the data there at the same time. So we wanted to change that to have like a really strong coupling in between those components to be able to say, I have this component, they are like even on two different characters, but at some point, like these two characters are going to be close to each other, and we want to have more interaction between the two. So we wanted to have like a strong coupling between the two, and we wanted as well to have kind of a weak coupling. So, for example, imagine you have like a character when you have like a clause that is simulating on top of it, you have like a groom, and you say, oh, I want to have like some kind of interaction between the two. I want to grab some information out of the clause and just send that, for example, to the groom. So we wanted to have like quick coupling in a sense. So it's not really like it's not solved at the same time with the same solver, but we want to extract some information out of one solver and pass that to another one. So it's why we integrated deformer graph into other kind of assets. The first one was like the solver component that I'm going to describe just after. And another one is the Dataflow simulation that I'm going to describe a bit later. So the Groom solver component has been introduced for strong coupling. So it's basically a component container on which you can just register blueprint functions. So you can add, remove group components. You can add, remove collision. So by collision for now, I mean skeleton mesh or static mesh, but it could be extended to other things in the future. And you have as well a way to set up like a deformer graph or Dataflow simulation on this component. And once you have that, the deformer graph has been extended to support the Groom solver. So now we have like two bindings in the deformer graph. Before there was only one, which was the Groom asset with only the strands data interface. Now we have you can access from the Groom asset binding to the guide, to the strands, to all the Dataflow attributes that you just set up before. And all the mesh data, I mean like all the skeleton mesh that has been bound to the Dataflow, to the Groom in Dataflow. But now we introduce as well a Groom solver binding, and the Groom solver binding has like access to all the evolution parameters that you can have into the solver, plus all the collision data interface. So with these two bindings, basically you can try now to have like more interaction between all the assets that you have into the Groom solver, plus you can have like all the collision with like all the skeleton mesh and static mesh that you have like registered to the solver. And I'm going to present you a bit like the Dataflow simulation. So it's really, really experimental. I will not advise you to use it out of the box now. It's far to be production ready, but since it's available and since it's used, for example, in all the editors, I wanted to mention it a bit. So the Dataflow simulation is a way basically to, it's a runtime Dataflow first. So it's not a construction one. It's like it's evaluated at runtime. And basically, how you're setting that, so you have like a lot of solver components. You can have like a flash solver component, a close component. You can have like a Groom solver component, even a chaos solver actor. And you can register Dataflow simulation asset onto this component. And like you have like a manager, which is a subsystem that's going to gather all the components that have been used in the world and that is using a Dataflow simulation. And is going to create some proxy and affect this proxy to each Dataflow asset. So after, if you open a Dataflow asset, you say, oh, I want to grab all my close proxy. I want to filter this proxy by this tag. And I want to advance the simulation in time. And after, I'm going to extract some information out of the solver. And I'm going to take other proxies which are the Groom one. And I'm going to enqueue, for example, here, a deformer graph. And I'm going to pass some data to the deformer graph. So it's like a way of a central place where you can launch a lot of solvers, and now it has been extended to launch as well deformer graph. So it's really, really handy. So this is, for example, a simple setup example. For example, if you have like on the top side, an outliner with a root actor, and you have a flash component, close component, a Groom component, a geometry collection component. Each one of them has been assigned to a Dataflow solver asset. The simulation manager will just register some proxy to each one of the solver assets, and you will have access to this proxy within each Dataflow simulation asset. And what's nice as well is like, if I go back here, when you are enqueuing a deformer graph into the Dataflow simulation, all the variables that you have set up in your deformer graph will be exposed into the node. And basically, you can start plugging things in as an input of the node. So things that could be like another variable from the Dataflow simulation asset, or some things that would come from like other solvers. Let's say, for example, you want to say, oh, I have like a closed simulation running, and I want to extract like a velocity field out of that, and I'm going to plug that velocity field directly into my deformers to be able to drive a bit of deformation. I mean, these things could be doable. But with all this new deformation in place, we wanted to have a way of like recording that. So we just modified as well how the Groom cache was working to be able to write cache. It was only reading cache in the past. And we plug that in the new Dataflow recording pipeline. So now you are like within Dataflow able to cache the result of any kind of deformation that you are going to set up inside a deformer graph or somewhere else. So I'm now going through like a simple setup example. So it's really simple, but it just shows you more or less the different steps that you have to go through in order just to have something running. So the first thing, for example, what we want to target is just to say, oh, I have like a skeleton mesh that is like going to be simulated, or that is going to be controlled by control rig, and I want all my curves, like from my guides or my strands, to follow that. So the first thing that you have to do is just to set up a skeleton mesh on the physics asset. So like in the skeleton mesh editor, and, you can set up the physics asset with like all your bodies, all your constraints, and yeah, and that's it. Then you have to use that skeleton mesh inside Dataflow. So in the Dataflow asset, you say, oh, I'm going to transfer the skin weights from like my skeleton mesh that I just set up onto my guide, that example. And you can edit them. So you can, for example, here is like a visualization of like my skin weights. You just select bones on the outliner, or it automatically shows off like all the different skin weights, and you can modify them, paint them, modify each vertex if you want. I mean, do whatever you want. Once you have that in place, you can create a deformer graph. So the deformer graph will just like grab the guides, and after we grab the bone indices, the bone weights, and like all the bone transform that you will have at runtime. Then it will plug all of these buffers into NetShell shader. And here you are just going to basically do the linear blend scaling in order to bind directly the curves points onto the bones. Once you have that, you just create a blueprint in which you just set up your Groom solver, your Groom asset component, your skeleton mesh component, and you can affect the deformer graph as you just set up before directly onto your Groom component. And once you have this blueprint ready, you just put that blueprint, put that into the Dataflow preview scene, and you will have that. And so after you just set an animation, and you are able to move it around, and you will have like, all your curves like following your bones. So again, it's like a really simple example, but it shows you at least like all the different steps that you have to go through just to have something working. And once you have like this kind of binding in between the two, you can do a lot of different things. You can even like use directly control rig. So for example, if you have like an asset like that, you can just like modify the bones on all the guides, on the strands will just follow exactly what you are doing. So now you have like full control of what you want to do. So just to recap a bit, like what we went through, like through all this session. now using Dataflow, it enables you to add like a lot of additional data to the Groom asset, and it really like opens the door to a lot of different things. Now, we have spent some time like working on the pipeline and just having everything kind of ready. And now we are going to spend way more time like just producing content, new nodes to do a lot of stuff. You can maybe even imagine in the future being able to groom things directly into that tool, because you will have like all the nodes just to modify the geometry. You will have all the tool just to paint something, just to modify something. So you will be able to do a lot of different things. You can already, but it will be expanded in the near future. We have like as well like improved all the bridge to deformer graph to enable to create custom deformation to GPU. I think in the roadmap we'll probably have like quite soon as well like that available in the materials. That way you could just as well define some rendering parameters inside Dataflow and just use that directly into materials. And we have now as well more interaction in between the different Groom components and with like other solvers thanks to the Dataflow simulation, even if it's a work in progress. And thanks to that, we'll have like quite soon as well like a new solver that will replace the old one. So it's a work in progress. It will be kind of available in 5.7, but really in experimental stage. So it will be improved over time and just be ready for the 5.8 release. So yeah, so thanks you for your attention, and if you have like any questions, feel free to ask.